Hello, I am David W. Parker, and this is Programming Today I Learned. This is the second episode in the algorithm series. We'll be looking at merge sort from CLRS, Introduction to Algorithms. So just brief instructions here, as per usual, and let's go back to this Jason Parks algorithm visualizer that we looked at before. You have it set up here for merge sort. We can run, and you can see what's happening here. Obviously, a lot of details going on down below. Be sure to play with this resource, it's fantastic. I have linked to it in the README. And let's actually go ahead and look at the algorithm now and see what's going on. So I've revisualized everything here and put it out as a console log. So we have this initial state of an array, and this is a divide and conquer algorithm, meaning we divide the original problem up into subproblems and then solve them individually as if they were the original problem and then combine their answers. So what we're going to do here is we're going to break this up into two arrays, and then we're going to break this array up into two arrays, and then we're going to break that array up into individual pieces. And then once we're down to either 0 or 1 indices, then we know we can't divide anymore. So here's the first step, is we're going to break this up into two arrays, 5, 2, 4, 7, and then we're going to break 5 and 2 out, and then we're going to sort that. So we have the left and the right, and then sort it, and then we have the next one, 4 and 7, and then we're going to sort it. So now we have this new left and this new right, and we're going to combine them together. Then we're going to take the other half and do the exact same with 1 and 3, 2 and 6. So we have this new subarray of 1, 3, and 2, 6. Combine those, and now we have 2, 4, 5, 7, and 1, 2, 3, 6, and then we output those. So obviously there's a little finagling going on here because we don't just push this array on top of that one or this one and that one. You have to loop through these and determine, is the 4 greater or less than 2, etc., etc. So let's go ahead and look at the actual algorithm here. So merge sort, we basically said, like I said, if there's 0, 1 left in the array, then we don't need to sort anymore. We want to go ahead and find the midpoint. This allows us to splice the arrays up into two different subarrays, and then we call this merge function here. So, and as you can see here in merge sort, this is where we are recursively calling the same function over and over again until we get down to the smallest possible array, which is, right, for us, 0 or 1. So, and then after we have those, we merge them together. So merge is where the magic happens. We're going to have a new final array here. And what we do here is we're pushing on infinity to the endpoints of each of the subarrays, left and right. And CLRS says that this is a great way to know that we can simplify the code. So if you ever hit infinity, you know that that's not going to be the smallest number to compare to. So we're going to iterate through the length of both L and R, which is K is the sum of those. And if the left indice is better or slower, so the left value of that indice is smaller or equal to the right one, we'll push that onto the new array first and then iterate that index. Otherwise, we'll push the right one on and iterate that index. And so that's how we get easily from 5, 2, 4, 7 to we have 5 and 2, and we push that, and it's 2 is less than 5, so we'll push that one on, and then we'll push the left one on, so on and so forth. And then when we have these two subarrays, we'll go ahead and push 2, and then we'll push 4, then we'll push 5, then 7, and over here we'll push 1, then 2, then 3, then 6, and over here we'll push 1, then 2, then 2, then 3, then 4, 5, 6, and 7. So it's pretty simple. If we're going to look at how this is broken out, this is kind of the tree that is created, and this is the example given in CLRS. You'll see that the divide step is basically dividing. It costs O of 1 because it's just computing the middle of the array. Recursively solving is 2t n over 2, and that's solving the subproblems. And then combining is going to be O of n times. And the height of the tree is log of n. And this is basically an example of a recursion tree. And we can see that the sum of the levels is cn log n plus cn. We're moving the lower terms, and we're left with O of n log n. So the worst case scenario on this is O of n log n, which is decent enough. And that's pretty much it for merge sort. If you liked what you saw today, please subscribe. Thank you. Keep coding.